for coming to this session. I know this is not a session related to Java or JVM languages, but in my opinion, Rust is a very interesting language, and I plan to show you some interesting features and why I think it's relevant for 2017. My name is Hanneli. I'm from Brazil. I work for a company called Codeminer 42, and these are some things that I like to do in my free time, including organizing meetup. I organize the Rust meetup in São Paulo. I also like Pokemon, so if you're playing Pokemon, and I know you are because I have a Nintendo 3DS with me that's pointing that there are some people that have a 3DS in this room, so let's please trade some Pokemons. I also like GIFs, so you're going to see some GIFs along this presentation, and hopefully this is going to help you to stay awake. I have some open source projects, not related to Rust, but if you want to check it out and do some contributions. So disclaimer, this is not a session about only Rust features. Of course, I'm going to show you some things, but my idea here is to do some comparison with Java, and then point you to the direction of what's important to learning Rust. So some architecture that Rust implemented and could be interesting for future versions of Java, or alternatives. Sometimes you can't use Java, and then Rust could be a potential alternative to you. This is not a Rust tutorial because, honestly, I think tutorials of 50 minutes in the middle of a conference are kind of boring. You can try Rust and do basic tutorials on the internet, but I want to emphasize the interesting parts of the language here. So you're going to see some theory. And some subjects, of course, may cause discussion, so the views here are on my own, and you are more than welcome to provide feedback or provide your own opinion. Of course, opinions about GIFs are also valid. So, of course, I'm going to show you the basics that you need in order to understand what or how Rust works. But I know this is a Java conference, so please, let's try to make peace instead of war. So what is Rust? Rust is a programming language, new programming language. And if you go to Rust website, you're going to see this amazing description that Rust is a general-purpose programming language, compiled, strong, and static typed, sponsored by Mozilla Research. It's designed to be safe, concurrent, practical language, supporting functional and imperative procedural paradigms. So Rust is not yet another language that runs on the top of JVM, but what does that long, beautiful, and lots, full of buzzwords description mean? So let's try to understand what's the meaning of that description and try to catch the most important features on the language. So why is Rust interesting? How many of you have worked or tried to work with embedded systems? Sometimes you don't have the option to use Java, right? Even I don't know, sometimes the company doesn't allow you to do so. Sometimes your hardware is so limited that, unfortunately, you can't run a JVM inside of it, right? So either if you have hardware limitations or business limitations, sometimes you just can't have the option to use Java. How many of you are Java programmers? How many of you like Java? So even though lots of people like the language, sometimes you don't have the option to use it. So which language did you choose? Anyone? Come on. You can use Java for embedded system. Go. What else? Bombshell. I don't know this one. JavaScript. Which one? Nothing wrong with assembler, so you can write your own assembly code. How many of you would, nobody said C or C++? C or C++. Along my career, I've seen that C and C++ are the most common alternatives for Java developers to pick up, and for some traditional companies to choose. So C and C++ I like, especially C++. I'm a big fan of C++. But it can cause some controversy here. C and C++, it may be very hard to debug. I mean, at least for me. If you have ever worked with a big C++ project with lots of templates, you may easily end up on a template hell. So sometimes you get an error, and the error means nothing. And then you start digging into your code, and then the template is not yours. And then it's very easy to mess it up. So it's kind of difficult to debug, especially if the project is large. It can also be difficult to maintain the quality of the code because, now I'm writing my own template, so who cares? Nobody's going to use this thing. Well, you never know. So for me, it's kind of difficult to maintain long C++ code. And the challenge, especially for C, manual memory allocation. Do you always remember to use malloc and free? I know that you probably have forgotten once, at least once, and then a new bug just appeared on your system. So Java is very convenient because we don't have to do this manual stuff, right? So C and C++ are a good option, but they can cause you some side effects. So it may be inconvenient in some circumstances, right? So what are we looking for in terms of a language? So personally, I'd like to have a language where I don't have to handle memory allocation manually, because for me, it's a pain in the neck. Sometimes I'm worried about business logic, about performance, but I don't want to keep taking care of these bits manually. That's kind of an extra effort. Usually, people try to get a strong and static type of language, or sometimes a strong and dynamic language like Python. But strong is important because it can help you to find, to prevent runtime errors. Early this morning, I gave a session about type theory where I could explain some of this idea of type systems. Lots of people like compile languages, so I think that's convenient, especially for embedded systems. Sometimes you're looking for a language that can provide you a fast environment, fast to develop and fast to deliver, and a good performance. Of course, you're seeking for a reduction in the number of runtime errors, and languages that come from an open source community are also important because, one, the source code of the language is opened, and if the community is active, you're more likely to have bugs solved and less pain when you find something that's not working properly. So those are the topics that I'm searching in a language. So I'm at Rust, and I noticed that Rust attends all these topics that I was looking for. So the description says memory safe, database free. So that's something that I'm looking for, especially for embedded systems. I was also looking for a compile language. Rust is compiled, and the compiler has been proven to be very efficient and blocks lots of runtime errors. I can easily perform an interface with C and C++, which means if I have any code written in C or C++, I can easily call it directly from Rust. We are going to see some examples. I think generics are an important feature, and Rust also has generics. Of course, I'm looking for the advantages of reusing my code, so I'm looking for polymorphism. And Rust is maintained by Mozilla, and the community around the language is impressive. Almost every day you see an activity on GitHub, and people are willing to help you, so they have some IRC channels, they have a very active mailing list, and people are really willing to help. So sometimes they even provide support via Twitter, so if you have a question, you just tweet, and they also help you. That's pretty amazing. So for me, it met all the requirements. And an interesting thing, the level of verbosity is pretty much the same as Java. So either you like it or either you don't like it. But that's the similarity. Also, Rust compiler is very verbose to explain to you what's wrong in your code. So I also like that. Not only the code is verbose, but the explanations are also verbose. So those are the top highlights for Rust. There is no VM. It's a compiled language. There is no GC. How many of you have heard complaints about the garbage collector in Java? How many of you tried to solve problems with GC? Is it easy? Sometimes it can be very difficult to solve problems with GC. That's why it's one of the top complaints in Java, the garbage collector itself. I'm not saying it's a bad thing. I'm saying it causes lots of complaints. So Rust has no GC. But on the other hand, even though it has no GC, there is no manual memory allocation and free. How is that even possible? So we are going to see a little bit about that on this session. And if you're using Rust, according to Rust manual, it's almost impossible to have a segmentation fault. So that is something that I'm very interested in. So I'm going to show you the quick structure of the language. So this is some Rust code. I hope people in the back can see it. It's a little bit small. So this is an example. Rust, different from Scala, Rust has no type inference, or at least it's very limited. So in Rust, you need to make explicit declarations for function parameters and return types. It's pretty much the same as in Java. You have to be explicit. Rust has some macros that help you to have a little bit of less verbosity, but that's pretty much how Rust code looks like. In Rust, everything is immutable, and we are going to discuss that, which means that if you declare a variable and then you try to reassign it to whatever other value it is, it's not going to work by default. So for example, here, we have the regular declarations for Rust. We are declaring like the immutable binding with the value 1. And if you get this value and we try to assign this to another value, that doesn't compile. If you want to have a mutable structure, we have to explicitly tell in the language by using mut. We are going to discuss this a little bit further, but by default, everything that you do is immutable. And of course, it has advantages and disadvantages. But that's one of the things that is going to prevent you from segmentation faults. Rust has a very good support for functional programming. It supports higher-order functions, so you can have a function in a variable, like here, we have n squared, and we can have this as a higher-order function. I guess, like, in terms of functional programming, it's a little bit better than Java. The syntax a little bit better, and we have some extra flexibility that we naturally don't have in Java. And it has several other features like tuples and enums. Enums are pretty much like the ones that we have in Java. It has structs, traits. Traits are some sort of equivalent to Java 8 interfaces. And why only Java 8? Well, because we can add default methods on Rust traits. So that's pretty much the same. So you might be wondering, like, it doesn't look very interesting up to now. I can see in your face, it's like, okay, why is this special? And most of this, like I mentioned, the feature of no segmentation faults, and that can be a potential feature that you're willing to see in your final product, right? No seg faults. So how can we achieve that? So in order to understand why Rust is so safe and why it can provide you no seg faults, let's talk a little bit about some internals of the language. So Rust has a feature called borrow. So in Rust, variable bindings actually own the value. So that means if I have something like let v be a vector and let v do v2 points to v, what do you think is going to happen? If I'm saying that a binding owns the value, should I be able to do something like that? Am I allowed to do such a thing in Java? Yes. But in Rust, if I'm saying that the binding owns the value, what do you think is going to happen? Do you think it's going to compile and have a runtime error? One, compiles and has runtime errors. Two, doesn't even compile. Three, I don't know what you're talking about. I'm talking about this code. So it doesn't even compile in Rust. And that's interesting. And again, this is one, about immutability, and two, about a concept that we call ownership. Is this convenient? Maybe. But what happens if you are really willing to pass the reference, or you're willing that your binding doesn't actually own the value? What can you do? Well, you can borrow the value that you have to another variable. And that's the concept of borrowing, right? So it may sound unpractical, but having this mode of ownership, once you see a binding and you don't explicitly do nothing, you can prevent several of memory errors. So like I said, if it's clearly your intention to have that value passed by another variable, then you can borrow it. So you have a special syntax to tell the compiler that, hey, I have a value here, and I want to borrow this value to another variable. So what can you do? You can use the concept of borrowing. So in this code, if you notice, we have this function foo, and we are using this symbol, the commercial, how do you call this? I forgot. N%. So, oops. So you can use this as a marker to tell the compiler, hey, I know what I'm doing, and I want to borrow this value to a function or to another part of my code, right? But you need to make it very explicit. Otherwise, since everything is immutable, you just can't pass the reference. Does it make sense? All right. So if you studied something in computer and science about networks or about memory management, it's very similar to the read-writer's lock. Do you remember this paradigm? What is that about? No, I don't remember. So according to this paradigm, either you have many readers at once or a single writer. You can't have both for the same block that you're handling, right? Either everyone just reads and nobody changes the value, or there is one single element changing that value. And then after that moment, everybody can read it, right? This way, we won't have different value. We won't have different elements reading different values, okay? So read-only doesn't require exclusive access. And exclusive access do not allow different readers. So you have a single reader every time, okay? So a single writer every time and several readers. So Rust uses a similar model here. What does it do? So you have, I don't know, some type that owns a value. If you don't say anything to the compiler, that type is going to own the value. You can also borrow it. So you're saying that this is a shared reader. And what is missing here? The exclusive writer, okay? So when you have the mut, the symbol mut, you're saying this variable is going to be my exclusive writer. So let's use some logic here. Does it make sense to have two variables with mut at the same block of code? No, because if you had this, you would end up with two writers, right? And this is not what you want at all, okay? So if you have two variables with mut in the same block of code, Rust won't even compile because it could cause potential memory issues in the future, okay? And that's very different for us who come from Java development. In Java, we don't have such thing, okay? So basically, these two here are immutable references, and the writer is what we call the mutable reference, right? So let's see an example of how the writers work in Rust. So we have mut here, which means we have a writer, and then we are borrowing the reference. Do you remember the symbol? We're borrowing the reference of this writer to another variable, right? And then we have to say to the compiler, hey, now this y here is someone special carrying a mutable writer reference. And this way we can pass values to different variables, right? So it sounds verbose, but the compiler is going to tell you every time if you make a mistake of trying to instantiate two writers the same block of code, the compiler is going to be yelling at you, don't do that. I won't compile your code because it's not safe, right? So what's happening here? This is not going to compile as well. So you cannot borrow X as a immutable reference because you are trying to borrow it at the same time. So either you have someone writing, or either you have people trying to read it. You can't do both at the same time, right? So Rust is going to try to protect your memory as much as it can. So borrowing can prevent iterator invalidation. How many times we're trying to loop across a list, and then your iterator breaks because some reference is wrong? This happens especially in C++. So if you have this model where either you write or either everyone reads, you won't break your iterators. You can also fix different types of database problems. And then, oops, sorry. And then by fixing the database problems, everything is guaranteed that you can just throw all your piece of codes away. It's a guarantee, because if you're exclusively reading or one element is exclusively writing, your code is not dirty, your memory is not dirty. There is nothing holding the reference for that block. So it's a guarantee that you can just push that block away. So if you know that, you can just throw all that instances away after that block. Do you need a GC? If your memory model holds the logic to tell you that after the execution, everything is safe for freeing, do you need a garbage collector here? Or can you just trust that this memory model works and throw everything away? You don't need it, because you are sure that there is no reference being held by that block of code. And that's interesting. So how do you get rid of that code that you just executed? How does Rust do that if you don't have a GC? So one thing here, you could easily mess up with borrowing, right? What happens if you free a variable that you're trying to land to a function? Does it work? That could cause you a potential problem. So let's see what Rust does in order to make sure that there is no reference being held when you free your memory. So don't worry, you don't have to do anything manual here. I'm going to show you the strategy. Rust uses a principle called lifetime. So basically, everything that's inside a scope, and by scope, I say the body of a function or a method. So Rust tracks everything that's inside a method by a lifetime. So for example, A1 has the lifetime A1. A2 has the lifetime A2, right? So from this line where A1 was declared until the end of the method, A1 is going to be alive. If you could control how much a variable leaves, could you extend how much it leaves and make sure that if you borrow that value to another function, things are not going to break? Does it sound like a good alternative? So you can use lifetimes in an explicit form, and then you can tell Rust how much time should a certain variable leave. So using this syntax that looks like Java generics, you can have control over how much a variable leaves. So you're not handling malloc and free manually, but you're handling how much time a variable leaves, right? So that's a different concept of C and C++. You can also control several lifetimes at once. So imagine that you have 2 parameters for this function, and then you want to control how much they live. So you can make them shorter or longer, depending on what you have here. And Rust uses the principle that by the end of a lifetime, it's going to free the variable. If you don't do anything explicit, when you end the method, Rust is going to free everything, right? But if you have something, a value that you're borrowing, you can make it live longer explicitly to the compiler, and then you won't have problems with the values that you're borrowing. So that's the idea of lifetime. I know that this seems to be confusing, right? The stick and the lifetimes that you're trying to explicit. They're trying to come up with a better syntax for this because this is very verbose. And you can pass any value here. So what I usually try to do, I try to pass a name that makes sense for the lifetime that I'm trying to control, right? But again, that's very easy to mess up. Hopefully, the upcoming versions are going to show you a little some better syntax here. And I've been trying some plugins, and the plugins actually are very helpful to control this lifetime here. They have autocomplete and things like that, so that's kind of helpful. But again, the syntax here can be kind of confusing. So lifetime is the tool that says that a GC is not necessary anymore. Because if you combine the exclusive readers or the single writer model, plus the idea that after each scope, Rust is going to free the involved variables, you know that you don't need a garbage collector. So GC is not necessary, mostly because lifetime and the borrowing system. With lifetimes, you also avoid dangling pointers. Because if you end a method, you know that everything is going to be released from the memory. So you can actually have a dangling pointer using this model, right? And again, you are not doing a manual malloc or free. I agree that if you tell me it's not very convenient to explicitly declare the lifetime, and it can be kind of verbose, I totally agree with you, but it's not malloc and free. And you have some rules to determine this lifetime. So for example, a variable could never live longer than the body of the method. And if you have a variable that you allocated in C++, for example, if you don't free that slice of memory, it's going to continue living, but you just can't guarantee what's going to happen. So in my opinion, this is less work than manual malloc and free. So is Rust always safe? I mean, I showed you 2 principles, ownership borrowing and lifetime. Does it guarantee that I'm not going to have any sort of trouble, like segmentation fault or anything else? What do you think? Flip a coin, yes. No. So, no, it doesn't guarantee that I can add a code that I'm calling from C++, and that code on C++ is not actually safe. So I'm going to show you a feature comparison, and I'm going to show you a scenario where your Rust code is actually not safe. But not only because of the language itself, but it's mostly because you're calling a C++ code on it. So Rust has good generics. I'm going to show you a quick comparison with Java. But first of all, do we have classes in Rust? No. We don't have classes in Rust, so a Java class like this, the closest that you can get in Rust is a struct and an implementation. Pretty much like C++. But you don't have actual classes. Actually, this is more like C than C++. You don't have the concept of a class, right? So for every struct that you declare, you have to declare the implementation of that struct. But you also have primitive types. So that means that both in Rust and Java, you have things that are not objects. You have things that are primitive types. You have the idea of an interface, like I said, in the interfaces in Java 8 can be translated to Rust straight. And again, in Java 8, you can have the default methods. In Rust, you can also have the default methods here. And you can also have methods that are going to be defined later. And again, like one interesting point in Rust is that you have a trait here, which is an interface. You can implement that trait for a certain structure. So for example, I have trait animal, and then I can implement animal for this structure that I have here. Or at the same code, I can also have the implementation for a pure horse, which has nothing to do with my trait. So that gives me some flexibility to my codes to act as an animal or not. And in Java, once you have a class that implements a certain interface, you can't have the same class, at least not with the same fully qualified name, acting on its own. So in Java, you have a permanent binding of behavior between a class and an interface, and you don't have such thing in Rust. So that's kind of interesting. So you can imagine the several possibilities that you could have in terms of subtyping, in terms of variants. You could have a more flexible code. Of course, you have to be careful, because the same way you can have multiple implementations of a struct for a trait, you can also have some trouble maintaining your code. But that's kind of interesting. Generics in Java, that's beautiful, isn't it? Like T extends comparable T. Well, in Rust you also have generics, but well, it's not that beautiful as well. One interesting point in Rust generics is that if you check this code here, it has a bunch of unrelated behaviors, and you can simply concatenate all the behaviors that you want, even though they're not related or dependent. So you can just concatenate. So this is what we call trait bounds. And again, use this for the good or for the evil. Like, it gives you extra flexibility. Like, if you're working with generics in Java, how many times you had to extend a class just to make it work with your generic code? Completely different, yes, but you can use the plus sign and just add. You have to pass different, how do you call it? I don't think you can. Can you use the plus sign? Yeah. Yeah, you can use. You can pass the different types that you want.
You can say T implements this and that and that.
Yeah, you can put T implements, and then you have to split them. But well, I think this is kind of more comfortable in terms of trait bounds. A quick mention. Rust also has arrays, but I don't think it's a good deal to compare with Java pure arrays, because in Java we use the object itself, the lists and whatever, trees and so on, things that come from collections. So it's not a good deal to compare like Rust arrays with Java lists. I don't think it makes much sense. However, Rust has a powerful array system, which we use with the vector class. And mutability. Again, like I said, everything in Rust is immutable unless you tell explicitly to the compiler that something is going to be a writer using mut, right? Or you have a macro holding a mut or something. But you don't have a native mutability, which is something that you have in Java, right? So let's go back to the idea of safety. I showed you borrowing. I showed you the ownership and lifetime. And this memory itself, if you have methods that are reading Rust and are obeying these rules of an exclusive writer or a bunch of elements reading a value, you should be safe. However, if you have any sort of interaction with C++ or native calls, you can't guarantee that you're going to have safety, right? So one thing that you can do in order to make a block of code safe, but you're not sure what's going to happen here, you can use the directive called unsafe. So if you're trying to break any of the principles in Rust, and by that I mean having more than 2 writers at the same block of code, you have to tell the compiler, hey, I know what I'm doing here. So you have to explicitly use unsafe. So this way, you can do whatever you want. However, Rust can guarantee that your code is not going to have dangling pointers. But you are allowed to write you're allowed to call C++ code or whatever. But you have to tell the compiler, I know what I'm doing here. And again, if you do that in one point, you can't guarantee that your code is going to be safe. The final program that you deliver, you can't guarantee that it's going to be safe. So that's under your own risk. But why do they even allow you to do so if it's a possibility to introduce some bugs? Well, sometimes you really know what you're doing. Or sometimes you have a C++ code that you need to reuse with Rust. You don't want to rewrite entire libraries. So you can do something like that. And then you encapsulate this logic into an external library, and then you can call it, right? So that's the idea here. The language doesn't try to limit what you can do, but it forces you to tell the compiler, hey, I should know what I'm doing here by using the unsafe. So you have to be explicit when you have some unsafe code. So is Rust perfect? Well, I think the answer is no. But it has some downsides, and I'm going to show you some of the downsides. But I think it's a promising language. The community is very active, and I pretty much like the idea of having the concepts of lifetime and also having the flexibility to write unsafe code when I know what I'm doing, or at least people think that they know that I know what I'm doing. So some downsides. I think Rust learning curve is not fast. Today, if you download Rust and try to writing some samples, you're going to see that it's very likely that the first 15 times that you try to compile something more elaborate than a hello world, like a calculator, the compiler is going to be yelling at you all the times, mostly because of the concepts of ownership and borrowing. Sometimes you're going to try to borrow a value to more than one variable at once, and the compiler is going to be yelling at you. Or sometimes you're going to forget that you have a writer, and you're going to try to add another writer. Then again, the compiler is going to tell you, hey, you don't know what you're doing. So I think the learning curve is pretty slow. There are lots of new concepts, mostly for us that are coming from a Java background. This idea of lifetime is not very intuitive. At least for me, it wasn't very intuitive. That's sort of pretty new language, at least in terms of industry. The companies are starting to adopt Rust only in the last 1 or 2 years, so that's pretty new. So don't expect to have an error and type it and go to Stack Overflow and have your and have an answer to your question. Don't expect that. You really need to go to mailing lists or I don't know IRC if you have some problem. I think also the verbosity of the language doesn't help that much, especially for lifetimes. Lifetimes itself is a confusing concept for several people, and the way that Rust proposes you to explicit the lifetimes is quite confusing. So I think that's something that they need to improve. But the Rust community has been trying to come up with a good response to all these problems. So the learning curve was not that good. So they created several documentation and resources. And I think that was pretty awesome. They created several free ebooks that you can download. They created some interactive websites that you can, you don't even need to install Rust. You can just use the online tool. The community, I mean, they are very responsive. I got surprised. I had a question and I just submitted an email to the mailing list, and like in less than 10 minutes I had a response. So that was pretty amazing. And in terms of framework, if you adopt Rust, what can you do? Well, it's impressive. Rust has a lib builder called Crate. So it's like the Ruby gems. And then people have been submitting libraries and applications of all sorts of types. We have tools for web development. We have tools for low-level programming. We have tools that automatically integrate with C++ and things like that. So I think that's pretty amazing. If you don't know, Mozilla is trying to, it's not even trying, they're also putting parts of Rust into Firefox. So the new versions of Firefox already come with lots of Rust code. So that's interesting. And again, if you come up with an idea like, hey, is there something that, I don't know, builds matrices of n dimensions for Rust? Yes, there is. Like the most unexpected things already have some Rust code in it. From web development to embedded systems to mathematics to whatever. So my points about the Rust type system, I think it's somewhat static and strongly typed. Like I said, I don't think it's totally strong or not totally static. I have my point about this. There is an interesting PhD thesis that discusses all these points here. You can take a look if you want. Performance. Well, I think Rust is doing pretty well in terms of, for example, the Mandelbrot, the famous fractal algorithm. It's way faster than Java. This is official benchmark. It's on the benchmarks game. It's one of the most popular benchmarks websites that we have. It's way faster than Java, but, well, not everything is faster than Java. Java 8 has been proven to be faster for other algorithms. So it's kind of half and half. So some things are way faster, some things are not worth it. A free gift for you. Here are some references. Like I said, I think the language is pretty new. I hope I could provide you some interesting insights on how Rust works. That was not meant to be a tutorial. I tried to come up with discussions of lifetime, ownership, and borrowing, which for me, at least, were the most confusing parts when I was trying to learn and understand how Rust works. If someone explained to me, like, hey, TLDR, too long didn't read, don't have more than one writer, and your code is going to work, or have only multiple readers without being mutable, your code is also going to work, I would have spent way less time in my attempts to make Rust code work. Here are some interesting code for you. Most important ones are these two last ones, where there is a gentle introduction to traits in Rust, and the author actually uses Java 8 interfaces to compare the behavior of the final result. So I think for you it's going to be very helpful. And there is an explicit blog post comparing Java and Rust. So I think this blog post is also interesting. The problem with this is I think the author is not using Java 8, so it's kind of outdated, but you can get the idea of some of the structures. Like I said, the community provided lots of free content. So there is a book, the Rust reference book. I also made other sessions about Rust. So if you're willing to try Rust and get the first steps, I made this presentation, Rust and Pokemons, where I explain, it's a Rust tutorial with Pokemon. So if you like Pokemons, you can check this presentation. I also made a presentation about Rust type system. There are other interesting references into this presentation if you are interested in a deeper analysis of Rust type system. Special thanks for JFocus community, and thanks for coming to the session. Do you have any time? Do you have 5 minutes?
Yeah, 5 minutes.
All right, do you have any questions?
So do you think Rust is sort of specialized in some areas? What do you use it for? I mean, can you use it for anything, or is it sort of mostly embedded systems, or should we replace Java and use it for web application frameworks?
Well, that's a difficult question. It's a matter of, for example, for web, I don't think it's mature enough for web. Although you have Servo, which is the web server, and Rust has been proven to be super fast for things like text processing. So if you're working with big data, Rust may be something useful, but not to replace your web project, but for doing specific tasks. Like that test about the fractal, it's a proof that Rust is very efficient for processing. But I don't think it's mature enough for web. I don't think it's mature enough for other things that Java does, like messaging, for example. I haven't seen any sort of messaging system with Rust yet. Maybe because nobody thought about it. But the ecosystem doesn't seem to be mature. Things that I personally use at Rust was, again, for bots, web scraping. My performance with Rust was way better than my performance with Java for the same machine. Rust also is being used into firmware development. So there are people developing drones with Rust. They are replacing all their C++ code with Rust. I've personally been to workshops where people were creating some systems for hardware in Rust, so that was quite interesting. So if I had to suggest 2 areas, maybe if you have to write code for parsing or lots of data and for firmware. There are some people using that in mathematics too. Any other questions? Oh, one question.
In the Java world, we are kind of spoiled with tooling, like IDEs, debuggers, everything is so incredibly good. I have experience with many other languages, it's not even half of it. Like, it's very difficult for me to use other languages because of that. Do you have anything to say about that in the Rust world?
Do you know IntelliJ? There's a plugin for Rust in IntelliJ. I think it's pretty good. Like I said, they were even able to help me with lifetimes auto-completion, which I was surprised. If I could say, I think it's about 80% accurate. There are some things that they can't do because, like I said, Rust is kind of tricky. There is no explicit type inference. So that's why the plugin is not going to help you at all in some cases. But I guess in 80% of the cases, that's fine. The plugin is not going to help you when you declare unsafe. If you declare unsafe, I guess the plugin ignores what's inside and forget about it. But a good thing about Rust is that the compiler itself gives you a very good explanation of what's going on. So usually, if you have a compiling error, you can just copy and paste what's going on and then see what happens. I think that's one of my best helps. Rather than auto-completion is the compiler messages. Any other questions? Well, I guess we're running out of time. So thanks for coming to the presentation, and I'll be around if you have any further questions. Thank you.